So you think you've seen it all with AI like ChatGPT? Well, get ready, because what's coming next is a whole different ballgame. We're about to dive into a new kind of AI, one that doesn't just talk about the world, but actually builds a version of it inside its own, well, mind, to understand and even predict reality itself. Let's get into it.
Just picture that for a second. A robot learning the incredibly delicate art of making sushi, not in some high-tech kitchen, but inside a simulation, a dream. I mean, that one line just perfectly captures what we're talking about today, AI world models. The whole idea is about learning by doing, but inside a universe made entirely of code.
You see, this dreaming is really just a super powerful kind of simulation. It lets an AI build up what you could call physical intuition. It learns about cause and effect, about gravity, how things bounce, how they squish, all before its metal fingers have even touched a single real-world object. This is a huge shift from just feeding machines data to actually letting them learn through experience.
Now I know what you might be thinking. Hang on, doesn't ChatGPT already kind of understand the world? And yeah, it can describe a picture, it can write you a recipe, it can even guide a character in a video game. But the difference here isn't just a simple upgrade. We're talking about a completely different category of intelligence.
This is where we really get to the heart of it. We are moving beyond just recognizing patterns in text and pictures, and we're heading into a totally new paradigm, building an internal understanding of how the world actually works.
So what exactly is a world model? Well, think of it like a simulator. The AI literally builds a little mini-universe inside its code, not just to know what things are, but to understand how they behave and what's going to happen next. You know, it's the difference between memorizing a cookbook and actually knowing how to cook.
And this comparison really nails the difference. A large language model, or LLM, is fantastic at describing what is by spotting patterns in huge amounts of data. But a world model? It's built to predict what if. It can run simulations of consequences, which, and this is the key, is a massive step towards real causal reasoning, understanding not just that B follows A, but why it does.
You know, probably the best way to think about this is our own brain. Before you make a choice, big or small, your mind instantly runs through a bunch of quick simulations of what might happen. That's pretty much what a world model gives to an AI, a kind of synthetic imagination that lets it plan and strategize. And hey, this isn't some far-off, futuristic theory. It actually has a pretty long history, and it's already being used in the real world right now. So let's take a look at how we got from this simple idea to the incredibly powerful tools being built today.
Believe it or not, the basic idea has been floating around since the 1940s, but for decades it was just stuck on paper, held back because we just didn't have the computing power. That all started to change in 2018 with a really cool breakthrough experiment. And today, thanks to the explosion in generative AI, progress is just off the charts.
And that brings us to the here and now, where we're seeing some absolutely mind-blowing tools pop up. You've got companies like Google building systems that can generate a playable 3D world from a single sentence. Others are building models specifically for robotics. I mean, these aren't just cool tech demos. They are the literal building blocks for the next wave of AI.
So how does this actually work in the real world, say for a robot? Well, it's this powerful four-step loop. First, you gather a bunch of real-world data. Then, you use that data to make your simulation more and more accurate. Third, you let an AI agent practice, not once, but millions of times in that safe virtual space. And only then, after all that practice, do you let it try in the real world. This totally solves a massive problem in robotics, making training way faster, cheaper, and a whole lot safer.
Okay. But this incredible power, it comes with some pretty profound risks. We absolutely have to talk about the dangers of building an intelligence that learns about our world not from reality itself, but from a simulation that's, by definition, imperfect.
There's this classic saying that just hits the nail on the head here. The map is not the territory. A simulation, no matter how good, is just a map of reality. And a map can be incredibly useful for sure, but it's always an approximation, it's an abstraction. It is never the real thing.
This image gives us a perfect metaphor for the core danger, which is this idea of a digital Plato's cave. These AIs are learning from millions of hours of compressed video and data. They're essentially looking at shadows of reality projected on a digital wall. They never get to experience the real thing. They're just learning from an echo.
And that begs a really critical question. What happens when the map is wrong? What are the consequences when the simulation gets reality wrong, even in just a tiny way? Well, the failures can be catastrophic. A self-driving model might miss some rare event that wasn't in its training data, like a child suddenly running into the street.
An agent might learn to cheat the simulation in a way that turns out to be disastrous in the real world. Or, and this is a scary one, these models could be used to simulate and manipulate human behavior on a massive scale.
So this brings us to the choice we're facing right now. We are the architects of this new kind of AI, and it's on us to figure out how to navigate both its incredible promise and its very serious peril. And it really is a double-edged sword. On one hand, the promise is huge. Safer self-driving cars, surgical robots that can rehearse a tricky procedure 1,000 times before ever touching a patient. But the peril is just as real, creating brittle systems that have hidden flaws we don't know about, or building tools that could be used for social manipulation and massive disruption.
This puts us smack in the middle of a classic trap known as the Collingridge dilemma. Basically, the moment when it's easiest to influence or control a new technology is right at the very beginning. But that's also the exact moment when we understand its long-term consequences the least. It means the time to be careful, the time to embed our values, isn't later, it's right now.
And so we come full circle, all the way back to our sushi-making robot. Its simulated dream isn't just some clever parlor trick. It really represents a genuine leap toward a new form of intelligence, one that's forged not just from data, but from synthetic experience.
The walls of this digital cave are being built as we speak. And that leaves us with a final, really important question. As we teach these machines to dream of our world, are the shadows they learn from going to reflect true wisdom or just a cold, calculated efficiency? At the end of the day, the choice is ours.